This video will continue our discussion over trig identities. We're going to work on adding these things now. We've had a few of these problems already, but we learned to work around them. So now we're going to work actually to add them. So let's do a reminder of adding fractions. It may have been a while for some of you guys. What we're looking for in the easiest way, we know when we add fractions, we have to have a common denominator. The easiest way to do this is just to multiply by the other denominator. But I multiply top and bottom of each fraction by that other number because I'm multiplying by ones. And when I multiply by 1, nothing happens. So I multiply straight across, and I get 8 over 12 plus, then I get 3 over 12. And then now I can add them that I have my common denominator, so this is 11 twelfths. All right, we're going to do that same thing here in part B. And so part B, I got 1 over cosine plus 1 over sine. And our common denominator, easiest way to do that, would be multiply just by the other denominator. So we're going to multiply this side by sine theta over sine theta. The reason I can do this is because that's a 1. And then I'm going to multiply this other one by cosine theta over cosine theta. All right, so we have that. And when I multiply now, okay, I get sine theta over sine theta cosine theta plus, and then I get cosine theta on the second one over sine theta cosine theta. Now I have a common denominator, so I can add them. This one isn't going to simplify at all. I get sine theta plus cosine theta over sine theta cosine theta. So we're going to be adding fractions quite a bit in these problems. So we need to be able to get a common denominator and add them together like that. All right, let's make it a little more complicated. So let me rewrite this, and we'll do our common denominator. So my common denominator, it's tempting to be like, oh, well, one's plus, one's minus, so I'm going to multiply by a negative or something like that. I've seen students do crazy things. We have to treat these as one term. So that 1 minus cosine is all one term. 1 plus cosine is all one term. So what I'm going to need to do is multiply just, again, by that other denominator. So I'm going to multiply top and bottom by 1 plus cosine on this side. And then on this side, I'm going to do 1 minus cosine. And 1 minus cosine. Okay, now I multiply. Okay, I'm going to get 1 plus cosine theta over, okay, when I multiply that out, notice one's plus, one's minus, so I'm going to get 1 minus cosine squared theta plus, okay, this is going to have a 1 minus cosine theta, and when I multiply that out, I get 1 minus cosine squared theta, like I did in that first one. Notice now I can add my denominators, or my numerators, sorry. My denominators are the same, so I can do that. I got 1 plus 1 is 2, and then I got a plus cosine and a negative cosine. Those are going to go away. So I get 2 over 1 minus cosine squared, and that's going to be the same as 2 over, I can replace that with its identity of sine squared theta, and we end up getting 2 cosecant squared theta. So these do take quite a bit more work, but it's the same as like problem A there. We just have to be careful with our trig functions that they cancel where they cancel, and we can change them to the reciprocal functions. Okay, problem D and E are two, these have tricks. If I want to get a common denominator here, what I really want is my denominator to be tangent, because I already have a tangent on 1, and this is tangent over 1. So the way I can create a common denominator here is I'm going to put a tangent on the bottom, but what it's going to cause is a tangent squared theta on top. Because notice now it's kind of like this, x squared over x is x. Same thing, but with tangents. So, but now notice I actually have it all over tangent. Right? I'm going to use that other trick. I'm going to go ahead and change everything to sines and cosines. So I'm going to get sine squared theta over cosine squared theta minus, it's going to be secant, so that's 1 over cosine squared theta. And that's all over tangent now, so that's going to be sine theta over cosine theta. So now this makes it evident what we should multiply top and bottom by. The top, and when you got to keep it equal, so we're going to do cosine squared theta on top and bottom, because that will cancel out all that top and some of the bottom. So that distributes now. And that leaves me, okay, it goes here and there. Cosine squared cancels, leaving me with sine squared. And then I'm going to get minus 1. Okay, the bottom, one of the cosines will cancel, leaving me with sine theta, cosine theta. Okay, we can actually take this a step further. Sine squared minus 1 is the same thing if I use my Pythagorean identity. It's going to be negative cosine squared theta. All over sine theta, cosine theta. And that is equal to, one of the cosines going to cancel, leaving me with, okay, it's going to be negative cosine theta over sine theta. And that's going to be negative cotangent theta. Okay, we have 2 more. So that's one trick there. This was that method I showed you guys earlier in a video where we didn't have to get a common denominator, even though we kind of did here. We did the tangent as our common denominator, then I used the trick. Okay, so we have 2 more here. Okay, E. So I'm going to switch it to, I would like my common denominator to be a cotangent. So I'm going to change that 1 to a cotangent over cotangent. Now they have a common denominator. So I'm going to put them together and change everything to sines and cosines. So I get sine theta over cosine theta plus cosine theta over sine theta, all over cotangent, which is going to be cosine theta over sine theta. Right, this one's kind of weird. What do we multiply by here? Well, I'm just going to take both. So I'll multiply by the sine to cancel those, and the cosines to cancel those. We can do that. I can multiply whatever I want as long as I do it on top and bottom. The reason being that's 1. Notice I'm writing my theta every time. I don't want to quit saying that. You need to make sure x, theta, whatever you're going to use it every time, or you lose points. Right? Right, so we have, that's distributing. So the cosine's going to cancel with the first one, leaving me with sine squared theta. The sines are going to cancel, leaving me with a cosine squared theta. And then in the denominator, I'm going to have sines cancel and then leave me with a cosine squared theta. This is equal to, I have a 1 in the numerator and a cosine squared theta on bottom. And 1 over cosine is secant, and we get the square as well. So there we go. Okay, we have 1 more, which I believe we've done already. Yeah, we won't actually do this. We've already done that problem. It's a repeat. I would recommend trying it maybe again if you need to, but notice that is the same problem as B. I meant to add a new one in there, and I didn't, but I think it's okay. This video is pretty long already. I have 1 more video going over over more examples.